All right, hello everyone, it's Mr. Wolfe here, and in this video I'm going to be going over number 6 on page 31 of your packet. So page 30 was looking at problems where you had to use Fg is equal to mass times the gravitational field strength. So really an equation showing the difference between weight and mass. Now it gets a little bit more difficult because we're going to be using this equation but within the whole context of everything we've been learning. But the nice thing is it's going to be really similar to everything we've been learning thus far. We're just adding in this extra thing right here. So a 686 Newton baseball player is sliding to a stop at home plate. So let's just say if he's sliding, he was initially moving maybe to the right. All right, he could have been moving to the left, but I'm going to have him moving to the right. Draw a free body diagram. All right, so if he's sliding, all right, here's the dirt that he's sliding into, the surface. He's on Earth, so the force of gravity. Normal force by the ground pushing back up on him. We know those are going to be equal to each other, so my net force in my y direction vertically is normal force minus my force of gravity. And if he's sliding into home plate, there's actually going to be no. He's definitely moving, right? But if you think about it, if you're sliding into home plate or whatever if you're sliding into home plate, you're not running at the same time. So there's no push force by your feet going this way, right? The only thing you're doing is you're sliding, and the ground is applying a force of friction that's opposite your motion. So the force of friction is the only force that that's going to be acting right here. Just to kind of show you another similar situation, here is our hockey puck scenario. So here's at rest, speeding up, constant speed, and then when it's decreasing speed, it already has momentum. That's why it's moving, right, to the right. But because the force of friction is going opposite, the net force and acceleration are opposite, and that kind of makes it. Except when acceleration and velocity are opposite one another, your object's going to slow down. All right. So my F net of x is just, you always do your positive minus your negative forces. Since I don't have a positive force here, I'm just going to minus my negative force. So force of friction. So really my force of friction is equal to my net force in this case. All right. So if I wanted to draw my net force, it's definitely going to the left. Things are unbalanced going to the left. And Newton's second law says that net force causes acceleration in the exact same direction. So acceleration is going to be in this direction too. All right, so now let's actually solve a problem. We know the force of friction is 45 newtons. Calculate the acceleration of the baseball player when he's sliding. All right, so a few things is we know that that acceleration should be negative, right, based on just our conceptual drawing up here. And let's write our equation. Acceleration is equal to net force divided by mass. All right, so I'm going to say, all right, well, acceleration, I have a number right here, 686 newtons. And in the past, a lot of times this number's been like in kilograms. And that is the mass, and we plug it in right here. But notice my unit. This is really, really important. It's in newtons. So this is my force of gravity in this case. It's not my mass. So I can't put mass in here just yet. So let's just leave this blank for now. Let's see if we could at least find my net force. All right. Again, from before, my net force in my x direction is just equal to my force of friction. So F net x is equal to negative, and then what my force of friction is, 45 newtons. And again, that negative just says that my force of friction is going to the left. All right. So I could take this number and plug it in right here, negative 45. All right. But I need my mass if I'm going to find my acceleration. So this is when we're including this next step that sometimes you'll have to do. Luckily, we've just learned a new equation that has mass in it. Fg is equal to mg. And we know the baseball player's weight. We know the force of gravity. That's 686 newtons. That's what weight is, right? It's like saying like a 180-pound player, right? 168 Newton player. So 686 is the force of gravity, the weight. I'm looking for the mass. And remember, g on Earth is always 9.8 newtons per kilogram. So now I'm going to find the mass. And the mass, in this case, when you do the math on it, is 70 kilograms. So I have the mass now because I have this equation about weight. I'm going to take it. I'm going to plug it into my equation and just rewrite it really quick. Divided by 70. When you do the math on this, negative 45 divided by 70 is going to give you an acceleration of negative 0.643 meters per second squared. In terms of decimals, you could do just 0.64 if you want. I did 3. I'm not going to be super strict on it. All right. Now remember, we have a negative acceleration. That's exactly what we expected in this case. All right. So this is really similar to what we've done before, but notice that I had to do an extra step because I didn't have my mass initially from my problem. So I had to figure it out using this equation. All right. Thanks for watching.